Okay, so this is question 6 from the 2017 A-level paper 1. So we've got this pulley and trolley system. Each trolley has a mass capital M. There are 2 concrete blocks of mass m, little m, loaded onto trolley A. And the trolley is released and accelerates to the bottom of the ramp where it's stopped by a flexible buffer. The blocks are loaded, unloaded from the trolley, and it is repeated. Here is the side view of trolley A when it's moving down the ramp. The tension in the wire when the trolleys are moving is T. Draw and label arrows on figure 9 to represent the magnitudes and directions of any forces and components of forces that act on trolley A parallel to the ramp as it travels down the ramp. So we've got T. We've got our weight. Now it says it accelerates, so my weight's going to have to be a bigger arrow. And I've got a normal force here. So I would imagine they're going to want some scale to this. So my weight should be quite large, quite a bit larger than my tension. Fx down there should be larger than T because we are accelerating. And then we've got the normal force reacting upwards so that Fx and N should add up to W. Okay, because they've said, because it does say to represent the magnitudes, I'm not sure if they're going to want, or how to scale they're going to want it. Let's take a look, see. Oh. So, that was dumb of me. Don't care about that, don't care about that. We've got one force that is parallel to the ramp, and it must be bigger than T because it said we're accelerating. Thankfully, the mark scheme does say ignore them, and it actually does want me to label these here that it is, this force is actually, because that one is equal to T, so they want it labeled as M plus 2M times G. And that one there, because it's parallel, is sine 35. Sine 35. I never get that right. But yes, sine 35. Yes, sine 35. Oh. Okay. So, assume that no friction acts on the axle of the pulley or the axle of the trolley's air resistance negatives will show that the acceleration A of trolley B along the ramp is given by mg sine 35 divided by m plus m. Well, okay. So, the tension is going to be equal to yes, mg sine 35. So, F net should be mg sine. Ugh. Actually, the tension itself, because it's talking about trolley B, this will be the tension, because the tension is provided by the other trolley, and this is the force from the trolley going the other way. I've got to pause this for a second. Okay, so I'm approaching this wrong. I made an incorrect assumption about the tension. Okay, if I look at trolley A, okay, so for trolley A, m plus 2m g sine 35 minus the tension. Oh, am I writing this right? Yes. Minus the tension is equal to m plus 2m times a. Okay, now because these things are connected, they're going to have the same acceleration. So for trolley B, tension minus mg sine 35 is equal to m times a. Okay, so I've got all the same variables in this. So if I add together these two formulas, this t and this t are going to end up canceling out, and I get m plus 2m g sine 35 minus mg sine 35, excuse me, is equal to m plus 2m a plus ma. Okay, if I expand and simplify this, is going to cancel out with that. And I'm going to end up with 2mg sine 35 is equal to 2ma plus 2 little ma. The 2 divides through. So mg sine 35 is equal to m plus m times a. So a is equal to mg sine 35 divided by capital M plus small m, which is our proof. Okay, so I just started my approach completely wrong with that one. Okay, so we have to compare the momentum. So because they're accelerating at the same rate, that means they'll always have the same velocity, which makes sense. Now that means that trolley A, so okay, so they're going to be at the same speed at any particular time t, but in the opposite direction. So, but A so because A has a greater mass, A also must have a greater momentum. And it's just remember that the momentums are going in the opposite direction. Okay, 6.4. Okay, so time taken for this. So we have to figure out what A actually is. And we just had that, so A is 30 times 9.81 sine 35 divided by 95 plus 30. Okay, and actually I have to multiply that by 0.25 because it's at 25% of maximum. So 0.34. Well, I'm actually going to go 0.337. Go keep one extra sig fig while I'm doing my calculations. Okay, so what I need is, so I know distance, I know an initial velocity is 0, I know, so I want to find time, I know my acceleration, I don't know my final speed, I know my initial speed, and I know my distance is 9. So I need to use my Suvat equation. And that is S equals U T plus AT squared over 2. But this is 0, so 9 is equal to 0.37337 t squared over 2. So 18 divided by 0.337 square root is going to be equal to t. And it says 53. That's not right. That's way too long. Oh, square root. 7.3 seconds. And check the mark scheme, and yes, we are right, 7.3 seconds. Okay, so for each cycle, so to remove 2 blocks, it's 19.3 seconds. So the frequency that we can do is 19.3 divided by 2. So it is 9.65 seconds per block. So now I go 30 times 60 divided by 9.65. Or actually, what I should do, because they do come in blocks of 2. So it's 30 times 60 divided by 19.3. So you can get 93 trips in there. 93 times 2. It's 186 blocks. So what did I say that was? That's 93 trips. So 186 blocks. 188 blocks. 186, that's right. You can't round up. You're not going to get an extra block. But apparently they accepted it if you rounded up. But that's it. 186 blocks in the 30 minutes. And that is question 6.